Okay, so it's going to be very similar to the presentation I gave before, but welcome to ACM. I'm Victor. Zach and I are co-president now. Who are we? Computer Science Club, but we're open to everybody. So if you're here, you're in the right place. So what we're going to do this semester, we want to connect you to your curriculum, get you hired, and also we want to empower your community. So 3 C's, right? What we're doing for connection, we've invited a bunch of professors, grad students, undergrad students to talk about the research they're doing. So you're going to hear about that, and hopefully that should give you some idea of what's going on here at UMD and opportunities that might be available to you. We're going to explore topics, hands-on project experience. We have several groups, and we actually have funding for it now, so that's nice. We want to participate in hackathons. We did only one last semester, to be fair, but we're going to try and do more in the future. There's Slack where you can interact with alumni, and there's pizza, which should be showing up soon, I promise. Career, we're going to invite companies to talk. We'll do networking like that. Weekly interview prep, resume review. This is going to be handled by the career prep group, which Zach, you're going to talk about in a little bit, right? Yep. Okay. And we're also looking for officers, which I will talk about in a little bit here. And for community, one thing we're going to be doing is we're going to be giving a talk at the Teen Science Cafe about tech addiction. We want to do more stuff like that, so if you have any ideas, reach out to Zachariah. And if you're interested in any of this, just, again, talk to us. Okay, so what's actually different? Officers, we need new officers. Zach and I are not going to be president. We'll still be around next semester, but we're going to be very busy. So somebody needs to take over the club, right? And so we need a vice president right now, a secretary, the treasurer. If you're interested in that, it would look great on a resume, right? And it would be very helpful to the club. Something else, we actually have access to our funds now, so we can help with paying for lead code premium for as many people as possible. We also have project funds. So if you want to do a project, we can help pay for, like, Raspberry Pis, Arduinos, that kind of thing. And we're going to be doing more career prep this semester, which again, Zach is going to talk about. And we're going to have more talks from, actual professors. So that should be pretty interesting. And if you haven't joined the Slack yet, you can use the QR code on the left here to do that. And the survey on the right is just to kind of help us cater to, like, make things more interesting for you. So I'll leave this up for a minute. Yes. What's Slack? Slack is kind of like, just think of it like more professional, right? It's not quite as good, but we have, again, a lot of alumni there. And if you want to interact with, ACM members or alumni, that's the place to do it. Any other questions?
If you don't join the Slack, it's going to be really hard for you to stay on top of what's happening in the club. A lot of the groups we're going to be talking about in a bit, all the communication will be happening through Slack. All the meeting notifications will happen through Slack. It's really important that if you want to be active in the club, that you join.
Yeah, we have individual channels for each group as well. You can join those groups. You can even make your own too. I forgot to mention, but yeah. And we also have a YouTube channel. So if you miss a meeting, every meeting is going to be recorded and uploaded to YouTube. And that's pinned on the Slack channel, I think so. Yeah.
The form on the left, or the thing on the left, just leads to a Google form. How do you get to the Slack from there?
We'll sign you up.
Okay.
Yeah.
We just need your email. I also recommend getting Slack on your phone, because that way you'll actually get notifications. Otherwise, it's really easy to get left in the dust.
Yeah. All right, Zach, do you want to talk about the career prep group?
Everybody get those links. Okay. My
goodness.
Very slow. Okay. Perfect. So as I mentioned, we're not just a hobby group where you come and listen to professors. We want to get you engaged in your curriculum and doing actual hands-on projects. So this year, the sub-teams are kind of the only way that we can really enforce that or really make it available. Nothing's required. So why should you want to join sub-team? They are excellent resume builders. You know, when I was interviewing or when I was getting interviewed for internships, everybody was asking, name a time you worked on a team and how you overcame challenges. You know, how did you work together with your group members? This gives you an opportunity to actually answer that question in a computer science realm. Very few opportunities are offered right now outside of this, other than maybe the software engineering class. But that's a group project that's required for school. Let's be honest, no one really likes those. These are fun, okay? These are things that you should feel passionate about and things that you want to do on your free time. So when recruiters ask you questions, you'll have a lot more passion. They'll feel it too, and they'll want to hire you then. It's also a lot of growth opportunities. Software engineering, that's quite a bit down the computer science track. If you want to get involved as a freshman in a group like this, you totally can. And you can just learn a lot. If you're a senior and you want to get involved, then you can teach. So in every way, everybody has an opportunity on these clubs. Like I said, real world experiences, nothing in this is fluff, it's all real. Collaboration, motivated individuals, and it's a lot of fun. So these are the offerings that we have this year for getting involved. Victor mentioned earlier, we are totally open if you are very passionate about something like, let's just say you want to make a group to write your own programming language. You could do that, totally open, just let us know. But these are the ones available currently. So I'm gonna let the other group come up and explain their projects to you. We're gonna start with hardware, Internet of Things. Take it away.
So basically, this is just my what is a computer? How does this thing work? I don't understand how it works. So like how is information passed from one device in a computer to another device, same computer, like processor, graphics card, or memory, you know, how does that work? So it's the hardware, you know, what actually makes the computer run. In computer science, we're taught, you know, how files and directories, how that stuff operates. But how does the data actually get transferred through the computer? And that's why I'm trying to figure it out. Problem is, I am a freshman, leading a couple freshmen, so we don't exactly have a lot of experience. So we were going to start out with Arduinos and Raspberry Pis, more basic stuff to hopefully, you know, take apart and put back together, that kind of idea. Learn what the components of a computer are and how they interact with each other. So if you have expertise in this field, please help us. If you're just in this field, please help us.
Looks is very modest. He's a freshman, he admits that, but he runs his meetings very efficiently. So
Run like 2 meetings.
what?
Run like 2 meetings.
Oh, they were good meetings. What can I say? Any questions for Lucas? Okay. Next one. All right, I'll take you away on this one. Game development is being led by Walker. He's a sophomore and he's done a lot of independent work on video games. So he's coming in with quite a bit of experience. And some of the things he really wants to focus on is getting everybody to work together on one game. So you'll be touching every aspect of video game creation, whether that's asset creation or physics simulation. Honestly, this isn't really anything I've done before, so I'm not a great person to talk on this, but Walker is very involved and he's very excited about this. So highly encourage this one.
As a little side note, Walker also, so the game engine that he's planning to use is the Godot engine, if you're familiar with that. And Walker also took like a video game class in high school, as cool as that sounds.
Yeah, so if you've never done anything like this before, a lot of learning. If you have done a lot, then you can make a friend with Walker so you guys can talk about this. Any questions? Okay. This career prep. Victor was saying, this is where we're going to be touching on interview preparation. We've got big part of tech interviews, not all of them. I think we're just gonna pause this because I think everybody will be distracted with pizza in the room. So we're just gonna get pizza first, then come back to our presentation. So feel free to come up. Pick whatever you want. We got plenty. That's also something that's released. Pizza will be coming partway through meetings. Donald's going to after this. What is what it is. No, I was.
You know, normally I would say yes. But considering everything else that's been going on lately, I'm gonna have to go with no.
I don't know about these other ones you're talking about, like raspberry. I think I have a starter kit for like basic service, like resistors and like stuff like that, but it could be a good project to, be part of it. What is like your schedule? You guys need like once a month? It's kind of in right now. It's still cool right now. We plan for once a week, but now that meeting, like you guys have access to well, I have access to monitor. So I just got access, but I don't know the rule as far as but they have like circle and table and stuff like that too. Yeah, you can talk to, there's a department office, electrical engineering department office, you can apply for, they have like a special card that is locked in. Say that's for a club. I think it's what it's yeah, so I'll look for thanks, Matt.
I didn't know you were an ACM.
I'm a mechanical engineer, but I'm in computer science. I enjoyed C++ a lot. It just makes sense to me. It's like I find it better than like JavaScript or something. You can do a lot with it, and it seems kind of sometimes. Yeah. Comes down a little bit. For the most part, yeah. Java is good, though, so if you ever get further into it, it does get even better.
Who's that one guy with the 4 majors?
I'll show you.
There's no reason that we can be involved. I want them involved so bad. Also, what the heck are you doing career prep? Whose idea is that?
Oh, I like this.
And some assets on the screen,
Really?
and I didn't notice it. Closed my laptop.
Damn. Nice.
Sometimes it's there, sometimes it's not.
Am I getting it?
No,
No?
I don't trust the Mac. I'm shocked it's not dead right now.
You'll get there. The assets still. Have you heard from women doing it all?
No, I didn't reach out.
Oh, you did? Yeah, it's okay to be fair. We need to do that. Right?
We might have missed, but honestly,
Okay.
because email.
Yeah.
That's why.
Sure.
Excuse me. It's okay if you don't. Would you mind giving a talk for like 1 minute on women in computing?
Yeah.
Too much. I always get too much.
Yeah. It's like UMD ACM. It's really convoluted. The link is in the YouTube channel. Or the sorry, the Slack channel. The Slack channel. Yeah. Yeah, the YouTube channel. Yeah.
Maybe if I had like a 40-hour. He's not, he's never gonna make that money.
And like.
Yeah.
Okay. We're gonna get back on task here. I love conversations, but you know, we got stuff to do. Anyways, back to career prep. We're gonna be practicing interviews every single week. So there might be a different topic in these career preps, but the bulk of the time is going to this. So if you want to apply to Amazon, we totally qualify. Don't think that I go to a small school, I can't apply. Absolutely not. You just need to be well prepared to interview. You can absolutely land these jobs. The biggest tough part about this is actually doing all the interviews. These interviews ask you an algorithm question or a data structures question, and you not only be able to answer it directly, but you need to explain your work while you're writing on a whiteboard or a Google Doc. And that's a lot more challenging than it sounds. You have to pretend like you've never seen this problem before. You're just coming up with stuff on the spot. We're going to help you prepare for that type of thing, so that you're not caught off guard. Because if you don't prepare, I bet money you will not get the job. And we'll also look at resumes. We'll work with the Career Center to make sure everything's up to snuff. Skill workshops if people want to learn some basic Python or React or things like that. That's really not going to be the focus here, but we can do the occasional skill workshop and of course professional networking. Everybody in the career prep committee is going to really get to know one another, and working through these problems gets you to meet other highly motivated individuals that could help you get a job later on through references. So are there any questions on this? Oh, yeah, one more thing to mention. We code premium. How many people in here know what we code is? Oh, okay. That's good. For those that don't know, like I was talking about before with the interview questions, LeetCode has a big bank of algorithms, data structures, those types of questions, and we'll be working through a bunch of problems. And having LeetCode Premium gives you access to the full suite of problems, also better answers to them as well. It's about $130 per on your own, and we're subsidizing $100 of it. So you only have to pay $30. And we would like to offer to everybody, we most likely will, but just a disclaimer, if we do have money, we're gonna offer it to the senior members first and go down from there. Just a heads up, probably won't happen, but want to let you know. Now we're going to questions. Okay. Now we're moving on to Bulldog Rocketry. We've done a bit of collaboration with them in the past. This semester, going into next year, our links are going to be much closer. The past Bulldog Rocketry hasn't done much computer science work. As it sounds, they do a lot of engineering, but over the next year, they're going to be expanding into newer areas of focus. The cool thing about Bulldog Rocketry that ACM can't necessarily do the best job at is providing a real world job environment. The club's currently very hobby and fun focused. These are still fun, don't get me wrong, but you have deadlines that you have to meet. You have managers that you will report to. You're going to be working teams, and there's a lot of people in rocketry. So I like to think of it as an internship that you don't need any experience to join, but you will grow. I've been in rocketry for the last 3 years. Had a ton of fun. And to say, oh, I'm in rocketry during an interview, people are like, wow, that's insane. I want to learn more about that. Just so you know, we're not little P rockets here. We're building 14-foot rockets that are going to 30,000 feet. That's as tall as airliners. So just to make that clear, rockets are dope as hell. So we are going to have two main focus areas for computer science students. This is not all the opportunities available in rocketry. If you have ideas, feel free to reach out. But these are the ones you most likely. First one is information technology, internal tools, and web development. We have a very bare bones website right now, and it's going to be implemented soon. And we're using Squarespace. In the future, it'd be really cool to offer you experience to work on the real code of a website. So if we get interest for that, that's definitely something we can explore. Also, we need to keep track. We say employees here, obviously, no one's getting paid. It's all database, but it's important to know what people are working on, how they're progressing on those goals. These are types of things that you would work on in an IT job. So if you're interviewing for an IT position, you can say, oh, I've actually already done that on my Bulldog Rocketry team. And lastly, internal reporting. There's a lot of other teams in rocketry, collegiate rocketry. Some of them are going to space. And it's important that we keep tabs on all these teams so that we can compare where we're at in our progress to theirs, see where we can grow. So a cool thing for this will be to figure out a way that we can keep tabs on all of our main editors and know what their developments are. Any questions on this? Okay. This is the second one, flight software. So right now we've got a pretty small working on our payload. And for those that don't know, payload is it doesn't have to be the long thing. It sounds dangerous, but we're just sending up our rocket 30,000 feet. Something's going to pop out, and it should do something cool. Our box is going to guide itself towards a road and land vertically. This road is not trafficked, so it's not going to hit any cars, but this is a heavy computer science challenge. So we're going to be using physics simulation, hardware control software, and computer vision. This is going to be a very big project, and we're going to finish it up this semester. But with that said, everything we do on this project will carry over to our larger rocket as a whole. So in the future, if we want to guide our rocket or develop our own in-house simulation tools, this is the avenue to do that. So this one's a bit more business focused. This one's a bit more engineering focused. Any questions?
If I want to know how do I do it?
Emma and Logan right here, and myself, we're all very involved with rocketry. Please reach out to us after the meeting if you'd like to join. There is also our Bulldog Link website. If you go to any club on campus, you can look them up and you say, I'd like to join your club, and then we'll get your contact information, get you set up so you can join our team. Okay. Now, lastly, this sounds like a lot of work, right? Why do I want to do more work? I'm already doing schoolwork. Like we said before, great for resume, great for job experience. A lot of fun, but if you're really busy and you don't have time to, really dive in the project, you don't have to. You can be involved as you want and as well as you are able. Don't think because one person's doing a lot, you can't do a little. You get what you put into it, and even doing a little can go a long way on your resume. any final thoughts or questions? Okay, please reach out to me after the meeting. Anything sounds interesting. I'm going to be sending out this survey on Slack after this. For people that want to do it right now. Put it in there. That is the end of my presentation. Keep an eye out for those types of things. Also, one other thing while we're on this. Group leads will be sending out when to meet invitations. This is very important that you fill those out. You can join a committee, but we unfortunately don't know your calendars just because you exist. So if you fill out when to meet, it's a short link, totally safe. It takes 3 minutes. If you don't fill it out, it's going to be really hard to collaborate. So in the past, we've had problems with that. That's a large reason why things didn't get fully out there last semester. So if you can fill it out, that would be excellent. And now I hand it back over to Victor.
Right. Okay, so we're going to be ending at
What time is it?
we're ending in 9 minutes because
Because we want, to be able to get to your classes, right? So I think
should
be time for me to give a brief presentation here. This is not related to what we've been talking about. This is just on something I've been using that I find kind of interesting. This is not it.
Okay, so this should be a pretty brief presentation here. This is about CUDA. Has anybody heard of CUDA? No? Okay. Who here owns an NVIDIA GPU? Yeah. All right. Cool. And this
I'll apply to you. All right. So CUDA, what is it?
First what problem does it address? So if we look at this code here, if we look at the function loop,
we can see that it is in fact has a linear time complexity, right? This is not good. We can do better. How do we do better? We use CUDA. I hope you like that transition there. So what is CUDA? It's an API and a runtime library for NVIDIA GPUs that is compatible with pretty much every language.
You can use C, C++, C#, JavaScript, Python, even Fortran. I don't think anybody here uses Fortran, but if you do, you're in luck. And it allows for parallel computing using an NVIDIA GPU. And this is possible because the GPU has way more cores than CPUs. So for example, the RTX 3090 has 10,496 CUDA cores. Does anybody have a 3090 in Flex here? No? Yeah. Me neither. And Intel i9s, on the other hand, have 10. Ryzen 9s have 16. I think there are some
Ryzen Threadrippers that have like 64 cores.
As you can see, GPUs have a lot more. And to be fair, CPU cores are much faster. But GPUs they're graphics cards, so they have to update a lot of information
at once. So they have a lot more cores.
Okay,
so what is parallel computing though?
So we
take a look back at this very simple function. It's basically just going through the loop and incrementing every element in the array by one, right? And it does this serially. It does it one at a time.
again, is really slow, right? It's not actually, but we could do better. We could just do it all at once. I say it's 01. It's not actually 01, but it feels like 01, right? What does this look like? So this looks more complicated than it actually is, because I added a lot of comments here. But just going through this, for the actual function itself, we barely modified it. We just took out the loop and just do one increment for every time we call this function. But going through, I'm just going to go through this one by one and kind of explain what's going on here. So first, we have to allocate memory on the GPU itself, because the GPU memory is separate from the main computer's memory, right? To do this, we pass in a pointer to the array and the size of the array, right? Then we have to copy data over from the normal memory to the GPU memory. And then we invoke the function, or as it's called in CUDA, the kernel. So beyond just the normal parameters here, we also have the, just realized I can't see my pointer on screen, so it's hard to see, but basically, beyond just passing in the normal parameters here, we also have these two in the angle brackets. The second one is the number of threads per block. The first is the number of blocks. So what are those? The number of, or a thread is basically one process. So if you were to pass in this, if you had 10, or one block with 10 threads per block, you're passing 10 threads. And that means basically that this kernel is going to get called 10 times, right? But since it's all being done at once, it's much quicker because we have the loop. So when we do that, each thread is going to have its own ID, right? So instead of using the index that we got from the for loop, into I equals 0, blah blah blah, we just pass in the thread ID, and then we can increment that because it's 0 indexed too. And after that, we just basically wait for the kernel to finish, and then we free the memory. We probably copy the memory or the actual data back over after we're done, but I forgot to include that. So why do we actually have to allocate memory though? So again, GPU has separate memory. This is called the device memory. It's much closer to the GPU, so it's faster. And in the past, we had to do this because they were separate, right? But recently there was something introduced called unified memory. Basically allows the programmer to treat all memory in the system as one. And this makes it much easier to program for. It's faster for purposes. Others not so much. We're running out of time, so I'm just going to kind of speed run this. It's not useful for every programmer though, because even though the actual function time can be a lot shorter, we also have to take into account things like starting up the runtime library, right? Or memory allocation and memory copies. So what would this actually be useful for if it's not faster in all cases? It's useful for linear algebra, using deep learning, simulations, which is actually what I've been using it in. And basically, if you're just dealing with large vectors and arrays in general, this is very useful. All right. And some things cannot actually be kernelized because, well, let's take a look at this. If each iteration of a loop depends on a previous or future iteration, it's going to basically screw it up, right? So if we went through this and started at 0, it'd be like 0, then 1. The next one would be incremented by 1, and then that would be 2. I probably should have a graphic here. But basically, this depends on each previous iteration, right? And if we do it in a thread and do it all simultaneously, it's just not going to be the same. I think we're out of time actually, but hope you find that interesting. Also, there's a course here. It's free and it allows you to actually do some coding in CUDA. So if you're interested in deep learning or machine learning or whatever, this is an extremely useful skill to have. You can use this QR code and go directly to the course that's offered by NVIDIA. So that is it for our first meeting. I hope you all found it interesting and hope to see you all next week.